Good morning. In today's episode, we want to take a few different data readings, data collections. I'm going to put my super ear inside the computer, and I would also like to do it with the engine running from my 2001 Corolla and my 2006 Honda Civic. Yeah, just before I begin, let's go ahead and do some things here. Read the waves. I'm using cursor. Oh, that sounds good. So it's going to have a lot of autocomplete. That sounds good too. Okay. I wanted to make a function that did this for me. And did this for me. So I think I'm going to do that. Definition. Build array. Okay, it sounds good. Let me see. Just see what cursor is doing right here. That he wants to return MP from buffer input data and data type. That remember that little big Eden flow of data for each byte, and H, which is a signed 16-bit digit, numeric digit, right? I have that in my notes somewhere. Signed 16-bit. Yeah. Is this what we're doing here for PCM samples filter MP from buffer? It is. So let's go with that. Now, I'm trying to think, were we not using these at all? I thought we were using this type of thing to get the wave in here. Is cursor making a mistake right now? So actually, I don't think we don't need this, and we don't need these. What we can do, oh man, I'm about to sneeze. Oh man, I'm gonna sneeze. We can actually like do this frames filter, and then okay, and it got the next one too, and then we can kind of get rid of these, and I think we need this part, so we're not gonna get out of that. Build array, and then let me look at this for a second. No, actually, I think we can do it like that. I'm gonna try something. Oops. I don't know why it did that. I just want to filter that. Just get rid of that. Comment it out. If we were to do it like this, it's the path, and we go ahead and do the tab. Let's just run it and see what happens. Do I have a VNV here? Source VNV bin activate. Okay, Python analyze wave. Build array is not defined. Oh, I see, yeah. We also need to, yeah, so these are for the, oh, let's test it out. I want to do like a main loop, but I want to see if it works first. Type error. Okay, that's what I thought. Now there might be a we need to have the wave open, so that's right. So knowing that, let's copy that and we'll do it right here. Oops. Whoa. Put it in there. I'll do tab because it already auto completed for me. Okay, whiff open and put data as F. Okay. Okay, yeah. This is what we want. Except we don't want input data here. We want frames. And I guess we don't need metadata, but we'll keep it in there anyway. Okay. Now let's try it. Okay, there we go. So it works. We'll do it that way. That way we can have it a little bit more, we'll get rid of this stuff here. And I wonder if I should have a, okay, we have the build graphs here. Okay. And do I need to have a function for this right here? Yeah, I guess we could do that. Addition, build the spectrum array. We'll just call it spectrum array. Spectrum array. Have that. And let me just make sure, verify that. I got that one. Oops, no, I didn't want to do that. Input data. Yeah, we also want the frequency. Frequency sample rate. We'll have it default to 192 kilohertz, and then I need to bring a little bit more into that. So we have our magnitudes and our frequency. So let me just do a control V here, get all this in there. Okay. Mag magnitudes and our frequencies. Put data, frequency. Okay, yeah, that's good. And then we want to return both of these magnitudes and frequencies, like that. Okay, and then we can do that down here. Where we're going to have it like magnitudes first, right? Gonna have it like this, and then going to take all this out. All that out. What was our function name again? Build spectrum frequency. Okay. Spectrum array, I mean. Boop. And boop. And then this one's going to take the, this one. Okay, yeah, it's got it. It's got it. And then, let's not forget our FS. Even though we don't need to put it there. But, okay. For frequency spectrum data. Okay. Okay. And these are the graphs. Okay, I see. Okay, this is good. Oh, excuse me. Okay, this is good. So, actually put this here. Oh, man. That. Okay. There we go. Cleaned up a little bit. Can still clean it up some more, but I think it's good. Now we need the main thing. I always forget how to do this. If that's what I wanted. Then main. Okay. Okay, we'll do it like that. We'll do it like this, and then we'll go ahead and put this inside of a def main. Okay. Okay. Let's test it, make sure it works. Okay. Other than maybe making some arguments, like system arguments, that we can put some arguments on the end of the command right here. Or maybe I'll just go in here and just add more of these down here. Yeah, it seems like it would be better to have a whole stack where it just takes all my arguments and does it for each one. So I might have to do some more modification later on, but I think that's good for now. Next, let's listen to the computer, where I'm going to set this device inside my computer and see what it sounds like. Alright, I'm going to record with Audacity. I'm going to put this inside my computer case so it doesn't short out the bottom of the
circuit board doesn't short out on the actual metal frame of the computer case, I'm going to use this little thing right here. Whoa! Just set that. Oh shoot! Set it like this. Raise it over here, like that. Let me open up that door.
Okay, so already we can see that it seemed like yeah, as it's picking up, it's really just like isolating it. It's like putting it inside of a box. Really, we're not picking up anything really. Just 100 to I think like 400 hertz. So yeah, I guess so. We don't need to take a picture of it. We'll go ahead and graph it. So I'm going to export audio, export to computer, and there's no band pass, and then inside computer case. Sign. Okay, 192 hertz. Okay, so export that, and yeah, we'll go ahead and save this project. Oh, and then we'll just have the what's it, AUP3. Okay, so we got that. Before we move on, yeah, let me just quit out of there. Let's go ahead. Actually need to open up cursor again, and let's see here. I have an idea. Parse arg. So whoa, I've never used that. Actually, never used that before. I usually use system. Argument parser. Yeah, I usually don't use that, but I usually do it like this. Get any arguments, extra arguments, and these are going to be the WAV files. Okay, and what we're going to do is we need to also do something for this. Hey, wait a second, I'm thinking. So we get that, we have an array, and then for WAV file and WAV files, we do main WAV file. Maybe we have to come up with a better name for this. We'll do that later. So the WAV file is this goes like right here, and wave path. Now it can be very wave path. Do wave file. We'll do title and I guess we can do FS, which will be 192. Right. Okay. And then we'll do it like fig wave, AX wave. That. We'll have our title here, and then time, amplitude, and then we can get rid of this because we have that now. Mag, frequency, PCM samples. Oh gosh. Okay. So, and then yeah, and also I need to remember to do this. So we want to have that inside there, like interpolated title, and then we just want to have like time domain wave. Yeah, we'll do it like this. And then over here, kind of do the same thing. We'll have the title in there. We'll make it an F string title. Okay. Frequency spectrum. Okay. So like that. Okay, let's test it out, see what happens. And then we will have to get a argument here. Let's do what we just did. No bandpass, and then wave file. Oh, okay. Source VNV bin activate because I quit it. And then let's do it. Oh, okay. We didn't import system. Import sys. Surprised it didn't like tell me that before. Oh, okay, I see. Wait a second. Okay, that kind of changes things. Okay, that changes things. So we want to put in multiple files, right, for arguments, but we put our title there. So let's do this. The title and this, we're just going to have that built in from the get-go. So that title is going to be equal to the wave file. And how do we do it again? I want to just get the name of it. Let me look that up right quick. So I kind of forgot. It's like OS and then get the file name for it. And you had to split something to get rid of the... I don't know why it takes so long. Okay, while that's loading, we'll do the FS 192. We'll just have that hard-coded in. Yeah, I guess we'll use this OS base name. Base name of wave file. Let me just print it out, see what it is. Oh, what the hell? Oh, OS path. Okay, and then what I'll do there is, I think what I was doing is OS split text. And then just having the first one. OS path split text. Oh, there was a way better way I was doing this. I don't remember. Okay, yeah, so that's what we want right there. Just get the file name, and then we'll do that, and then what is it saying? No, oh, okay. I just need to go through and check my arguments here. PCM samples. PCM samples. Okay. Okay, here it is. Okay, do that. Yeah, so basically what we did is just get like, it says we have more than that, but it's mostly like right in here. Yeah.
Is this working? Okay, it's working. Okay.
Okay, so we took our two recordings for 2001 Toyota Corolla for 1ZZFE and a 2006 Honda Civic non-SI R18A1. Let's go ahead and um, run what we did. We'll do the inside the computer case, and then we will do the 2001 Corolla engine and the 2006 Civic engine. Oh man, I'm glad that worked. Okay, here's the wave up here. I'm going to have the waves on the top right here, and then their frequency spectrums on the bottom. Um, Wait a sec. Uh-oh. Oh, okay. We have an issue. We have an issue. Let's see. Why is it doing that? Why is it doing that? Okay, we need to fix one more issue with this. We'll just do a print. Wave files. See what happens. It has all of them in there. Okay, let's see. Let's see. Let's do it over here. Oh! Oh. Wait a sec, that was weird. If I close them, then they... Oh, I see. I see, I see. Okay, I see. Okay, let me try something right quick. We're going to do something a little different. So build wave and fs graphs. So what we're going to do is, okay, wait a sec. How do we do this again? We need a dynamic name. Or we can just throw it into like an array or something. What we need to do is not that. That needs to be down here. And this needs to actually return something. So it must return, right? Everything returns things. Okay. So it must return a tuple with fig wave and ax wave and fig uh, figure for frequency spectrum and our AX frequency spectrum. Okay. Let me try. Okay. Oh man, I don't remember how do you do that? Um, I think we'll just have like an array of plots, right? Let's have that, and then just gonna have like this array of plots append. Throw those inside, and then for graphs and array plot. Oh, wait a sec. I need to think about this for a second. I know this isn't going to work. This isn't going to work right here. So, well, yeah, because of that. But it's probably not going to work because the logic is probably all messed up. Yeah, and then also I should probably be printing that out too. Just see if it populates or not. Well, actually, I think that worked. Okay, I wasn't expecting that to work. Well, it worked. Huh, that's weird. It's not supposed to work. But that works. That's probably not the best way to do it, but yeah, we can now compare these out. Yeah, so I mean, 2006 Civic is louder. Yeah, I'm just kind of interested in to see what Gemini had to say about this analysis right here. I copied and pasted all the graphs here, and yeah, let's just go through and see what it says. Based on the graphs provided, here's a breakdown of the acoustic signatures you've captured. Okay, so inside the computer case, and then we also don't have our bandpass filter on there anymore. The signal is remarkably consistent and square, likely representing the constant mechanical hum of cooling fans and drive motors. The spikes you see are probably transient electrical noise or the physical vibration of the case panels. Frequency spectrum. Um, this is very flat or white noise heavy. There aren't many sharp peaks, suggesting the noise is a broad spectrum drone rather than a specific harmonic pitch, right? Um, yeah, and I want to find spikes. I want to find spikes there, right? That's why I want to have the ultrasonic MEMS microphones and see if I can get like a spike and to get some type of well, I guess that's the thing though. Like it's gonna be like vibrating so fast. It's gonna be a flat line too, wouldn't it? So okay, I guess that makes sense. But still, we want to get some better, higher frequency sensing microphones in there. 2001 Corolla engine, the time domain wave compared to the computer. This has a much higher amplitude. It's like 15 to 20 units. I need to get my amplitude to be probably decibel to be the log function probably. Set a future improvement that I can do. But for now, we're just doing it like this. Frequency spectrum, you have a very dominant peak around 11,000 hertz. This is quite high for an engine. It might indicate a specific belt squill, an alternator whine, or a bearing resonance rather than the low end thump of the pistons. The 2001 Corolla is like old as hell. So it's got a lot of these like noises, right? Um, I probably need to go look around at it and stuff. It also that's kind of interesting because there's also I think the full trims are high and then also at high RPMs it just loses power like crazy. So there might be some type of vacuum leak or something going on. So this is a really nice diagnostic tool, and this is kind of another reason why I want to make this thing is because it could detect leaks that you can't hear, and it could detect frequencies that you can't hear. And well, even without the ultrasonic microphone, I mean, 11,000 hertz is already a frequency that we can't hear, right? So it's already kind of a diagnostic tool already. 2006 Civic engine. Um, this shows the highest energy of all three, with amplitude swings reaching 40 times. Interestingly, there is a visible dip or variation around 0.2 um, to the 10th power. Uh, exp- 10 to the 7th power. 10 to the 7th power. Which could be the engine settling into an idle or a change in mechanical load. Um, this engine is much busier in the low to mid range. You have multiple strong peaks around 4,000 hertz and 6,000 hertz. This suggests a more complex harmonic profile than this Corolla, likely capturing more of the valve train and the intake noise, which it would make sense because I have a colder intake and then the full exhaust and everything. And then also, I know there's some more problems and stuff I need to be fixed with that. My tuning, I need to do some more tuning, but I haven't hooked up my AEM O2 sensor wideband yet to the ECU. I need to do some more Honda tuning, some more third gear pulls. I know my foil map is completely messed up. There's like some lines that are crossing and whatnot. Key observations, noise floor. The computer case recording is very quiet relative to the engine, serving as a good baseline for ambient mechanical noise. The Corolla whine, that sharp spike at 11 kilohertz, and the Corolla is a standout. So there's something going on with the Corolla. Um, it would probably a pulley or high pitched vibration. Resolution. The Civic recording seems to have captured a broader range of engine dynamics. Okay, that's cool. That's really cool. We can look at it again. Okay, yeah, I see. That's a huge spike right there. Absolutely huge. Super huge right there. Look at that. Oh no, something's going on. But yeah, what a nice tool. And then we could also see some things going on here. Okay. But I mean, maybe this is the natural frequency of a four banger engine. This is a lot higher, isn't it? Okay, that's it for this video. Some data analytics and whatnot. Have a good day. We'll be back soon.